In this video, we have a Phoenix Axioline IO distributed IO drop connected to a Modicon M340 using Unity. We gave the Phoenix Axioline IO drop the address of 192.168.03, and we came into the Process Data Watchdog, and we set up the Watchdog timer for a value of 500 milliseconds here. From there, we went to the Modbus IO table, and we can see what the actual slices are, and we can see that for depending on the drop, we can see that there's different registers. Here we see 8,000 for the inputs, 9,000 for the outputs on this drop, and we can see different inputs and outputs for each of the different slices that get attached to it. The other thing we need to do is look at the Modbus register overview. You'll notice that under here, register 2006, the command register, is a key register for resetting a network fault. If we do have a network fault or cable disconnection, we need to put the word 20 hex into that to recover from that fault. So over on the Modicon side, we come into the DTM browser, and you can see we've added an IO drop, Phoenix Axioline. So to configure that, we come into the Phoenix, come into the properties, we gave it a variable name for ins and outs, we gave it an address setting of the 03, and we gave it request settings. So these request settings match up with what that Modbus address table was for the actual Phoenix. So we have the three different transactions for the different IO slices, and we added a fourth one for error reset. For the error reset, we have register 2006, one word, and that's where we'll actually put the 20 hex to reset it in a fault. Underneath this, we come under items, and you can see here for the input bits, and now we gave the items names for the inputs because it's a discrete card for the first transaction, and outputs, we gave the real world outputs. On the fourth transaction, we actually came in here and highlighted the watchdog, and we gave the name of watchdog reset that will be under the variable name Phoenix Axioline. So when we close out of here, we can see that we go into this the health bits for the scanner for the Ethernet card. You can see that all four of those transactions are healthy inside of here. And if we go into the inputs and outputs on the card, we can actually see my N0, the variables I named them, and the Q0s, QXs. And I can come in here and I can force those values. And I can see the LEDs turn on and off on the actual device itself. And if I disconnect the cable, you actually see the transactions go all to zero. If I reconnect the cable, none of the transactions come back except for the fourth one. The first three will not come back because they're trying to write to real world outputs on the distributed IO drop, and that can't happen until we have a reset. So the fourth transaction is actually where we need to put the word 20 hex inside of this watchdog timer here. And how we do that is we actually come to my ladder, I right click, and I set that value to 1. I use an operate block where I force 20 hex inside of there. If I come to my table, I can see that's actually decimal 32. And then I come back to my ladder and I turn it off. And it puts a value of 0 back inside here. But when we do that, you'll see all the transactions come back to 1 and everything's healthy. The red light goes away in the module, and I now have control of the module again. I can turn things on and off. The other way, if you don't want to use a transaction method like that with a scanner, is you can come inside of here, and you can use function block diagram for something like this, where you actually stuff the word 20 hex into word 2006. So we can see there's the number 2006. Number of words is 1. And here's the address to go to that syntax for the address that we're looking at there. Thank you.